Some people look 10 years younger than their actual age, and science has finally discovered why. Watch this entire video to learn exactly what makes your face age slower. The deep sleep repair mode. While you lie unconscious in your bed at night, your body runs the most sophisticated anti-aging operation known to science. Most people assume sleep is passive and everything shuts down completely. The truth is, your skin cells work harder between midnight and 4 in the morning than during your entire waking day combined. During the deepest stages of sleep, your pituitary gland releases a flood of human growth hormone that triggers regeneration across every layer of your skin. Collagen production spikes dramatically during these hours. Damaged cells get replaced with fresh ones rapidly. Blood flow to your face increases by nearly 40%, delivering oxygen and nutrients your skin desperately needs after battling pollution and UV rays throughout the day. Scientists at university hospitals' Case Medical Centers studied sleep quality and skin aging extensively. People who consistently got poor sleep showed more fine lines, uneven pigmentation, and reduced elasticity in their skin. Their skin also took significantly longer to recover from sunburn and environmental damage compared to well-rested participants. The well-rested group looked measurably younger, and their skin bounced back from stressors almost twice as fast. Those who appear to be younger than their age often guard their sleep with serious consistency. That rested glow you notice on some faces is not just a feeling but visible biology in action. The cortisol drop effect. There is a hormone that ages your face faster than sun exposure or poor diet combined. When cortisol stays elevated for extended periods, it becomes genuinely destructive to your appearance. High cortisol breaks down collagen and elastin, the two proteins responsible for keeping skin firm and bouncy. It triggers inflammation that manifests as redness, puffiness, and uneven texture across your face. It disrupts your skin's ability to retain moisture, leaving it dry and prone to forming deep lines. During quality sleep, cortisol levels plummet to their lowest point of the day. This creates a window where your body focuses entirely on repair without stress hormone interference. Your skin barrier strengthens considerably during these crucial hours. Inflammation calms down, and proteins that maintain youthfulness rebuild without being broken down simultaneously. A study published in Clinical and Experimental Dermatology confirmed that participants with high perceived stress had significantly more visible signs of aging on their faces. Researchers traced this mechanism directly to cortisol's destructive effect on skin cell function and collagen degradation. People who seem to age slowly often sleep differently than those who age rapidly. Their bodies get that nightly cortisol drop consistently over years and decades. This difference accumulates into changes that everyone notices but few understand properly. The exercise reversal effect. Your skin responds to regular physical activity in ways that go far beyond surface-level improvements. Exercise does far more than burn calories and build muscle tissue in your body. It actually reverses structural changes in your skin that were previously considered permanent effects of aging. Researchers at McMaster University in Ontario conducted a groundbreaking study that changed how scientists view exercise and skin aging. They examined skin samples from volunteers over the age of 65 who had been sedentary for most of their adult lives. The outer layer of their skin appeared thickened and dry, while the inner layer had thinned considerably. Both hallmarks of aged skin that most dermatologists consider unavoidable after a certain point. Then these same participants started a simple exercise program consisting of jogging or cycling twice per week for 30 minutes at moderate intensity. After just 3 months, researchers took new skin samples and found the skin had transformed significantly. The skin structure of these 65-year-old participants now resembled that of people in their 20s and 30s. The outer layer had thinned to a healthier state, while the inner dermis had thickened and regained its youthful structure. The mechanism behind this transformation involves substances called myokines, which your muscles release during physical activity. One myokine in particular, called IL-15, was found at significantly elevated levels in the skin of exercising participants. These chemical messengers travel through your bloodstream and communicate directly with skin cells, essentially instructing them to behave younger. Exercise also increases blood flow to your skin by approximately 8 times the normal rate during activity. This surge delivers oxygen, nutrients, and removes waste products that accumulate in skin cells throughout normal daily living. Over time, this improved circulation keeps skin cells healthier and more capable of regeneration. Both aerobic exercise and resistance training produce anti-aging effects on skin, though they work through slightly different pathways in your body. A Japanese study on middle-aged women found that resistance training improved skin elasticity and dermal thickness while reducing circulating inflammatory markers that accelerate visible aging. The women who lifted weights showed measurable improvements in skin structure after just 16 weeks of consistent training. People who look younger than their biological age often share a long history of staying physically active throughout their lives. Their skin has received decades of enhanced circulation, myokine signaling, and reduced inflammation that accumulates into differences visible to anyone who looks at their face. The gut-skin axis deep inside your digestive system lives a complex ecosystem that scientists only recently discovered has a direct connection to how young your face appears. Your gut microbiome, a collection of trillions of bacteria residing in your intestines, communicates constantly with your skin through pathways that researchers call the gut-skin axis. This connection works through multiple biological channels that influence everything from inflammation levels to collagen production in your skin. When your gut bacteria are balanced and diverse, they produce beneficial compounds that travel through your bloodstream and support skin health at the cellular level. When that balance gets disrupted, the effects show up on your face as accelerated aging, increased wrinkles, and loss of that youthful glow people associate with health. Researchers at the Center for Microbiome Innovation at UC San Diego analyzed data from over 1,000 female participants across multiple studies examining skin aging markers. They discovered that the diversity and composition of skin bacteria directly correlated with transepidermal water loss, which is essentially how fast moisture escapes through your skin surface. Higher bacterial diversity meant better moisture retention and fewer visible signs of aging across all age groups studied. The gut influences skin aging primarily through a process scientists call inflammaging, which describes the chronic low-grade inflammation that accumulates in your body as years pass. An unhealthy gut microbiome produces inflammatory compounds that circulate throughout your entire system and accelerate cellular aging wherever they travel. Your face, being highly vascularized and constantly exposed to the environment, shows these inflammatory effects more visibly than almost any other body part. Studies on centenarians, people who live past 100 years, reveal fascinating patterns in their gut bacteria composition. These exceptionally long-lived individuals tend to harbor higher levels of beneficial bacteria like Akkermansia, Christensenellus, and Lactobacillus compared to younger people with age-related health problems. Their gut microbiome appears to protect them from the inflammatory cascade that ages most people prematurely. Probiotics and prebiotics that support gut health have shown measurable effects on skin hydration, elasticity, and wrinkle depth in clinical trials. The connection between what happens in your intestines and what appears on your face has been confirmed. Through multiple peer-reviewed clinical studies, people who maintain youthful appearances often have digestive systems that function optimally, support rather than sabotage their skin health. The optimism advantage, the way you think about life, appears to physically alter how quickly your body ages within your tissues. Researchers at Harvard University and Boston University School of Medicine tracked over 70,000 women and 1,400 men across 3 decades to understand how psychological outlook affects longevity and physical appearance. The results revealed that individuals with the highest levels of optimism lived 11 to 15% longer than those with negative outlooks on average. More significantly, positive thinkers were 50 to 70% more likely to reach age 85, which researchers define as exceptional longevity. This matters for your face because positive psychological outlook correlates with lower levels of chronic inflammation throughout the body and reduced oxidative stress at the cellular level. Both inflammation and oxidative stress directly contribute to collagen breakdown, skin thinning, and the formation of wrinkles that make faces appear older than they actually are. The National Institute on Aging confirmed these findings in a separate study involving 150,000 women from diverse racial and ethnic backgrounds. Women with positive outlooks lived on average 4.5 years longer than those with negative mindsets. The association held true across all demographic groups studied. Only 25% of this longevity benefit could be explained by healthier lifestyle behaviors, meaning something deeper in the biology of positive thinking protects the body from aging. People who maintain hopeful expectations about their future experience fewer negative emotions and encounter daily stressors less frequently, according to follow-up research. This reduced stress exposure translates directly into less cortisol circulating through their system and less inflammatory damage accumulating in their tissues over decades. The stress shield your body's response to stressful situations determines how rapidly your face ages beyond what most topical products can address. Chronic psychological stress triggers a hormonal cascade that systematically breaks down the structural proteins, keeping your skin firm and youthful looking. When stress becomes your baseline state rather than an occasional response, cortisol levels remain elevated continuously throughout your waking hours. This persistent elevation activates destructive enzymes that specifically target and degrade collagen and elastin fibers in your skin tissue. The destruction happens invisibly at first, but accumulates into visible sagging, deeper lines, and loss of facial volume over months and years of sustained pressure. A clinical study published in the Journal of Cosmetic Dermatology examined 40 women with varying stress levels and measured specific markers of skin aging objectively. Women reporting chronic moderate stress showed measurably impaired skin barrier function, increased roughness, and reduced antioxidant capacity compared to their low-stress counterparts of identical age. The stress response also shortens telomeres, the protective caps on your chromosomes that determine cellular aging speed throughout your entire body. Researchers found that individuals with high perceived stress had telomeres, equivalent to someone 10 years older biologically, meaning their cells were aging at an accelerated rate invisible to standard medical assessments or mirror reflections. People who appear younger than their actual age often process difficult situations without sustained physiological activation in their nervous system. Their bodies return to baseline quickly after challenges, rather than remaining in prolonged states of hormonal stress that compound facial aging throughout their lifetime. The telomere secret: inside every cell of your body exists a biological countdown clock that determines how quickly you age at the most fundamental level possible. Telomeres are protective caps sitting at the ends of your chromosomes, functioning much like the plastic tips on shoelaces that prevent fraying and unraveling over time. Every time your cells divide to repair, damage, or replace old tissue, these telomeres shorten slightly as part of the replication process. When they become too short to protect chromosomal integrity, cells enter a state called senescence, where they stop dividing and begin releasing inflammatory compounds into surrounding tissues. This accumulation of senescent cells drives visible aging throughout your body, including your skin. Researchers in the Netherlands conducted a landmark study examining why some people appear younger than others of identical chronological age. They found that participants who looked 5 years younger than their actual age had measurably longer telomeres and performed better on cognitive tests. These same individuals were 15% less likely to develop chronic obstructive pulmonary disease and 24% less likely to have osteoporosis compared to those who looked their age or older. The connection between telomere length and facial appearance runs deeper than surface correlation alone. A study on identical twins demonstrated this relationship conclusively by comparing siblings who shared exact genetic profiles. When one twin appeared older than the other, that twin almost always had shorter telomeres and typically died before their younger-looking sibling by an average margin of several years. Your lifestyle choices directly influence how rapidly your telomeres shorten throughout your lifespan. Chronic stress accelerates telomere degradation significantly, while regular exercise, adequate sleep, and diets rich in antioxidants appear to slow or even partially reverse the shortening process in some cases. Researchers at the University of California, San Francisco found that comprehensive lifestyle changes could increase telomere length by approximately 10% over a 5-year period in study. Participants. The Nobel Prize in Physiology or Medicine was awarded in 2009 to scientists Elizabeth Blackburn, Carol Greider, and Jack Shostak for their discovery of how telomeres and telomeres protect chromosomes from degradation. Their work established that biological aging operates on a measurable timeline encoded within your cells themselves rather than being purely random deterioration. People who look significantly younger than their years often carry longer telomeres that allow their cells to continue dividing and regenerating tissue effectively. Their skin maintains thickness and elasticity because the cellular machinery responsible for producing collagen and replacing DMAG cells continues functioning at levels typical of much younger individuals. This biological advantage compounds over decades into the visible youthfulness that others notice immediately upon meeting them. The Hydration Foundation water makes up approximately 60% of your total body weight and over 70% of your skin tissue composition. The amount of fluid you consume daily affects your skin's ability to maintain structural integrity and resist the visible signs of aging that accumulate over time. When your body becomes even mildly dehydrated, it prioritizes water distribution toward vital organs like your brain, heart, and kidneys. Your skin, being the largest organ but least essential for immediate survival, receives reduced hydration first when supplies run low. This redistribution leaves skin cells less plump, reduces elasticity, and makes fine lines appear more pronounced than they would in a fully hydrated state. A clinical study published in the journal Clinical, Cosmetic, and Investigational Dermatology examined how increased water intake affected skin physiology in healthy women over a 30-day period. Participants who added 2 liters of water to their daily consumption showed measurable improvements in skin hydration at both superficial and deeper dermal levels. The improvements were most significant in women who had been consuming below-average amounts of water before the study began. Proper hydration supports collagen function by maintaining the water content within connective tissues that gives skin its bounce and firmness. Dehydrated collagen fibers become stiff and less capable of providing structural support, which accelerates the sagging and wrinkling process that makes faces appear older than their biological age warrants. The connection between water intake and skin appearance extends beyond simple moisture levels in your tissue. Adequate hydration helps your body flush toxins through sweat and urination that would otherwise accumulate and contribute to dullness and uneven skin tone over time. Your kidneys function more efficiently when properly hydrated, reducing the burden on your skin as a secondary elimination organ. People who consistently consume adequate fluids throughout their lives maintain skin that functions more efficiently at every level of its complex structure. Their cells plump properly, their collagen remains flexible, and their overall complexion reflects a brightness that dehydrated skin simply cannot achieve.
Regardless of topical products applied externally.
The sun protection accumulation ultraviolet radiation from sunlight causes approximately 90% of visible facial aging according to dermatological research spanning multiple decades. The difference between someone who protected their skin consistently and someone who did not becomes dramatically apparent by middle age and beyond. UV rays penetrate skin and damage collagen fibers, elastin networks, and cellular DNA in ways that accumulate invisibly for years before suddenly becoming noticeable. This process, called photoaging, creates wrinkles, age spots, uneven texture, and loss of firmness that far exceeds what chronological aging alone would produce in protected skin. An Australian study followed participants for 4.5 years, comparing daily sunscreen users against those who applied protection only occasionally. The daily users showed no detectable increase in skin aging over the study period, while occasional users aged measurably during the same time frame. The researchers concluded that consistent sun protection essentially paused the visible aging process entirely for those who maintained the daily habit. The protective effect compounds dramatically when sustained across decades of consistent behavior. Someone who wore sunscreen daily, starting in their 20s, arrives at 50 with fundamentally different skin than someone who began protection at 40. The damage prevented in those 20 years cannot be replicated by any treatment or procedure. It's currently available in modern dermatology. People who look remarkably young for their age often share a history of sun-conscious behavior stretching back many years. But sun protection alone does not explain everyone who defies visible aging despite having average habits and minimal skincare routines throughout their lives. MC1R gene discovery. Scientists have now identified the first gene directly linked to whether your face appears younger or older than your actual chronological age. This discovery, published in the journal Current Biology, represents a breakthrough in understanding why some people seem to defy visible aging effortlessly. The gene is called MC1R, and researchers at Erasmus University in the Netherlands discovered it by analyzing over 8 million genetic markers in thousands of European participants. When researchers compared perceived age against actual age in genetic profiles, MC1R showed the strongest association with looking younger or older by a significant margin across all participants studied. People carrying certain variants of this gene looked up to 2 years younger than those without these variants. It's completely independent of their skincare routines, sun exposure, skin color, or lifestyle choices they maintained throughout their lives. MC1R carries instructions for a receptor that plays roles in inflammation regulation and cellular repair throughout your body beyond its known function in producing melanin pigment. Researchers believe these additional functions explain why certain variants protect against visible aging, independent of surface-level skin characteristics that dermatologists typically examine. The implications of this research extend beyond simple curiosity about why certain people age gracefully without apparent effort. Scientists are now investigating whether the protective mechanisms triggered by favorable MC1R variants can be replicated through targeted interventions for those who did not inherit these genetic advantages naturally. The receptor influences how skin cells respond to damage, how efficiently they clear inflammatory byproducts, and how effectively they maintain the structural proteins that keep faces looking firm and youthful over time. Understanding your genetic predisposition does not mean accepting defeat if you lack the favorable variants in your DNA sequence. The research confirms that while genetics provide a baseline, the lifestyle factors covered throughout this video still account for the majority of how your face ages visibly. Those who combine favorable genetics with protective behaviors compound their advantages exponentially compared to those who rely on DNA alone. If you found value in this video, subscribe to the channel and share it with someone who needs to hear this.